So 3.4 gets into library functions and also piecewise defined functions. Question 1 says match each graph to its function. So the first function is the absolute value function, which is going to be y equals the absolute value of x. Remember, absolute value means distance from 0. Distance is always a non-negative number. So when you take the absolute value of a negative number, it actually is going to be a positive value. If I'm using the calculator, I can type in y equals and then to find the absolute value. If we hit the math button, if we slide over to number, the first one has absolute value. So if we go to math and then go to number, you'll see that ABS parenthesis guy. So if I choose number 1 there and put X in, it'll graph it. So if I hit the graph button, notice my window is a little bit off. So to make my window normal, if you hit the zoom button, number 6 will reset the window. So the absolute value function kind of takes on that look. So remember, if I make a table, we can use -1, 0, and 1 for your x's. If I substitute -1 in for the x, the absolute value -1 would be a positive 1. 0 would still be 0, and 1 would be 1. So also, if you look at your table, you can see more ordered pairs as well. So notice that you basically, it kind of takes on linear, except when you get to the left side of the graph, the negatives actually bend upwards and go in an upward direction instead of a downward direction because of that absolute value. So it looks like this graph here is going to match with this here. The identity function is defined by y equals x. So it's going to be linear. So again, here you're just basically looking at the graph of a line where if I use -1, 0, and 1, -1 is going to be -1, 0 is going to be 0, and 1 is going to be 1. So it's really just going to be a line. So if I use the graphing key y equals and clear that off and put just an x in, if I graph it, notice that we just have a line that kind of goes across there as a positive slope. So notice how this equation down here, this graph here would be the identity function. Cube function would be y equals x cubed. Now, to really see how it works, if I choose a -1, a 0, 1, and a 2, that'll give you a little bit better view of the graph, because a -2 cubed would be a -8. -1 cubed would just still be -1. 0 cubed is still 0. 1 cubed is just 1. And 2 cubed would be 8. So notice how this graph will start to make what we call a snake-looking graph. It's kind of like this one down here. So again, if I look at it from y equals x cubed, again, cubed can also be found by hitting the math button and number 3. If I hit graph, notice how you get that graph there. You can also see the table and see that, notice how -2 was -8, -1, -1, 0, 0, 1, 1, 2, 8. So remember, if you want to let the calculator generate a table, you can. But the cube function is the one we call kind of snake-like. So the square function is the one we call quadratic, y equals x squared. Is our quadratic function. So the square function is really going to be this little curved graph like this. It's going to take on the square function. So again, if you just want to graph 3 points, -1 squared would be 1, 0 squared would be 0, and 1, 1. You'd have those 3 points, and that would help you create the parabola, if you remember, it's kind of a U-shaped graph, or it's also called a parabola. So this is the word they sometimes associate with square functions, is the word parabola. A constant function is basically y is equal to a constant. So remember, a constant is just some number. So you won't see a variable. It's just going to be some number. So the constant function is going to be a horizontal line. So it's going to be that graph there. So the constant function is a horizontal line. And it's going to be defined by whatever the constant is, whatever that y value is. Which leads us to what's called the reciprocal function. So the reciprocal function takes on this graph right here. So it's going to be, reciprocal function is going to be y equals 1 over x. This is the most simplest one that we have. It's going to take on that look here. So notice that this is the one that actually has a domain restriction. So notice how the domain, this one, x cannot equal 0. It could be anything else but that. So there is a domain restriction there that it's every number but 0. So, if we set literal notation, make that a little bit cleaner, we could say the set of x is such that x cannot equal 0. Notice also, as far as the y values go, there's no way to make the numerator 0 either. So this also has a range issue. The range is going to be the set of y's such that y cannot equal 0 either. So it's going to have these, what we call boundary lines. So notice that the x-axis is a boundary line and the y-axis is a boundary line. So the y-axis is the domain restriction. The x-axis is actually the range restriction, because y equals 0 represents the horizontal line and x equals 0 represents a vertical line. So that's what's interesting when you graph them. So this kind of takes on this look here, these little miniature, almost like parabolas in these opposite quadrants. So I'm going to not get too much detail on that one at this point, but that's kind of how that one looks as well. Let's see, make sure not those there.